content here. So I work in the science department in EOP and the Earth Observation Directorate of ESA. And I would like to talk to you a little bit today about what Earth observation can do for the green transition and the information needs related to the green transition, and how we use interoperability best practices to streamline and operationalize solutions for this. So let me start with just a couple of high-level slides here that you might have seen before, but I thought it could be interesting for the audience here to review this. So, this is just an overview of the current missions that ESA is developing. So considering the ones in preparation, in operations, and the heritage missions altogether, this is something like 77 missions, right? And the message here is simply that, we live in this golden era of remote sensing, and it's a really cool field to work in for all of you. At ESA, of course, we do much more than managing and operating missions. A lot of the work we're doing is also on applying the data and working on innovative applications. And a lot of these are driven by international policies. So, here very prominently, of course, the climate policies, the SDGs, the Ramsar policy, but then also increasingly the European Green Deal is at the center stage of attention here. And in the last years, we've developed some applications and some projects specifically addressing the information needs in the green transition. And the first initiative that I wanted to bring to your attention here is the Green Transition Information Factories. So this is something that we started 2 years ago. And the objective here is really to showcase and demonstrate what Earth observation can do for the information needs related to the green transition, to provide actionable information for a range of different users, including policymakers, industry professionals, or citizens, to better understand the related challenges and opportunities, but also to engage in the public discourse on this important topic. It's also about developing dedicated capabilities in terms of value-added products, of new indicators, and develop interactive tools to engage users and provide decision support. So we initially addressed these 5 key priority domains here that you see down there. So energy transition, mobility, sustainable cities, carbon accounting, and EO adaptation services. But we're expanding this now further. The first demonstrator that we developed was done for Austria, but really now we're rolling this out to other countries. This infographic here shows you a little bit the overall process. So this is strongly a user-driven process. So we go through several iterations with stakeholders in the different countries to identify their specific information needs related to the green transition, capture these requirements, and then work with our industry partners together to develop some initial solutions. We then go back to these stakeholders and demonstrate what we have developed, and then take their feedback really into account and further evolve these services and solutions, and then look at really operationalization of the services, and then also transferring the ownership of the GTIF, of the Green Transition Information Factories, to the respective stakeholders. And down here you see a few of the examples that come out of these activities. So there's really some added benefit for the involved stakeholders in terms of information support systems on air quality, on energy transition, on heat islands, or sustainable urban cities. So on a technical level, GTIF is basically a front end that's based on the EODASH framework that's developed as part of the EuroDataCube project by EOX with some other industry partners. And in the backend, it's using EuroDataCube, which again is a federation of different European platform services, and now increasingly also OpenEO and OpenEO platform. And I'll talk a little bit more about that in detail a little later on. So I don't want to spend much time on demonstrating here to you what the GTIF tool can do, but I wanted to show at least one example so that for those of you who have not seen this, that you get a little bit of a better understanding of what this tool does. So the example that I'll show you comes from the energy transition tools, and specifically here looking at the site suitability assessment for wind energy. So the first thing that users can do here is visualize the wind power density calculation, which is a modeling output that uses ERA5 reanalysis data, but then also Sentinel-2 data to estimate surface roughness. And it provides you a quantitative measure of how much wind energy you can produce in a given area, given different turbine heights. Users have the full metadata here, stack-based, and of course they can do overlays with all sorts of constraining variables and ancillary layers. And then here, users can go into the specific site suitability analysis by using these constraint sliders that you see on the lower right. And there they can constrain the wind power density raster here basically for constraining variables related to terrain, so elevation and slope. And then also, for example, the excluding protected areas from the analysis. And then looking at some very critical variables like this one here, this is the distance to settlements. And as you know, in Europe, this is often subject of a heated debate, how far a wind turbine should be located from a built-up area or a settlement. And in Austria, this is the example for Austria. So in Austria, even the required distance varies from 1,500 meters to 500 meters. And in a densely populated country like Austria, this is a quite detrimental variable, and users can here explore a little bit what is the impact of constraining this analysis to an enforced distance of 500 or 1,000 meters, after which not much remains. So what the users see here is basically the remaining wind power density, areas that are considered suitable considering the applied constraints. And they can then very easily overlay here different ancillary layers. They can also look at the monthly long-term averages of the wind power density for a given administrative unit. They can export these infographics that summarize your analysis that you can then use to discuss this further. And you can, of course, also export these zones into a GIS environment. So we did this first demonstrator for Austria. But since the beginning of the year, we have kicked off 3 new GTIF projects. These are the so-called GTIF Kickstarters. And the objective here is really, on the one hand, to develop some new capabilities addressing the information needs in the green transition, starting with a new national showcase. So demonstrating these very quickly after 6 months in a national context. And then working on the robustness and scalability of these capabilities, and then demonstrating them after 1.5 years in a multinational regional showcase. All of these capabilities should then be refactored into reusable cloud-based on-demand services. I'll talk a little bit about that further down the line. So this is just an overview of the kicked off Kickstarter projects. So we have a GTIF Baltic that focuses on phase 1 on Lithuania, then Germany, Poland, Estonia, and Latvia. We have GTIF UKIF. This is focusing on UK and Ireland in phase 1, and then France in phase 2. And the so-called Cerulean GTIF, which is focusing on the North Atlantic coastal waters between Canada and Greenland and Northern Europe. This is just an overview of the capabilities that we're developing with these different teams. This is the GTIF UKIF. So they are looking, for example, at the potential for bifacial solar farming, so considering the surface albedo for photovoltaic energy production. They are working on a capability that allows downscaling of particulate matter PM2.5 down to street level. They are working on 2 capabilities for methane plume detection, one open source based on Sentinel-2 SWIR bands, and one based on the Earth Daily Analytics superspectral satellite constellation that is yet to be launched. And then they're also looking at building heat emissivity and thermal anomaly mapping to guide a little bit the policy considerations where building insulation improvements should take place. And the 5th capability that we're developing is using albedo time series to develop early warning indicators for drought onset. So it's just one example of the capabilities that the Kickstarter projects are developing. And this is just a couple of screenshots here from a capability that I didn't show you. So this is simply the a machine learning based capability for energy infrastructure mapping. So in this specific case, we trained a Sentinel-2 model to detect windmills. And it's quite interesting because I always thought, or we always thought that European governments, they have information on where wind energy or energy, renewable energy in general, is being expanded. But that is not the case. So in Austria, actually, there's a couple of government agencies like the environmental agency that do not have up-to-date information where new windmills are set up or new photovoltaic farms are set up. And they have a strong interest in using an Earth observation-based capability that can do this in a repeated way and in an objective manner, right? So for us, the objective here is we don't want to set up, another contract change notice with a project consortium to run this for another country. We want to develop this once and then refactor it into a reusable cloud-based service implementation. And that can then be reused by anyone to run simple things like these energy infrastructure mappings for any area or time frame that you're interested in. So that's really now the focus in the activity, that we build this ecosystem of reusable capabilities. And we used this wind energy turbine detection as a starting point. So the initial Python implementation was refactored into OpenGeo UDP. Take a look at that in a minute. And it's now being made available in the ESA network of resources, where any user can request this now to be sponsored by ESA for any pre-commercial use. And we already have some interested entities such as Eurostat that would like to run this for all of Europe. And we're going to meet with them to discuss that this week. So we did this here for Germany, and the results are really quite good. The feature that this convolutional neural network exploits here is the shadow that's casted by the wind energy turbines in the very light seasonal imagery. So this is September, October imagery, where you have this long casted shadow. This is orthophoto imagery on the right, but you also see this in the Sentinel 2 10-meter bands. So what do we mean when we say interoperable on-demand services? So we have, through the last years of activities that we have run, identified two interoperability best practices that really allow to deploy application algorithms in the cloud as reusable on-demand services. And one of these best practices is using OpenGeoHub, user-defined processes and process graphs. Then, of course, stack metadata to facilitate discoverability and everything. And the other best practice that we are working with is the OGC application package standard. And I'll show a bit more on that in a minute. So to transition these capabilities into cloud-based on-demand services, we need to refactor the code or wrap it around one of these interoperability best practices. We need to expose the services and the applications in marketplaces. And I have to say, all of these EO marketplaces, 10 years ago, they were really quite disappointing, I think, in terms of the functionality that they offered. But I think now we're at a point where we can expose much more functionality in a really useful way to the user community. And the third element then is to expose the service also in the network of resources. So this is an ESA initiative for sponsoring European cloud-based services, where it's then offered at a commercial price, but also ESA takes over the sponsoring of this service for any pre-commercial usage. So just a few words on the OpenGeo UDP, because I think it's an interesting concept here for the audience. And I think you have a few speakers, at least this week, that will talk about OpenGeo. So sorry if I duplicate things here, but so we developed OpenGeo platform on top of the OpenGeo API, which was developed as part of the Horizon 2020 project. So I think it was a really quite nice initiative. So this started in 2020, and we're now concluding the main contract. OpenGeo platform is deployed with 3 operational backends. So in EODC in Austria, in Terrascope in Belgium, and with Sentinel Hub. And all of this is then aggregated through a central endpoint, which is linked to OpenGeo platform, which is reachable through opengeo.cloud. And then, of course, since beginning of the year, also there's an OpenGeo backend in the Copernicus data space ecosystem, but this is not yet part of the operational OpenGeo platform service. We're still identifying the best ways of integrating these two service offerings. This is the OpenGeo platform, and we kind of run and manage it at this time still. And I think most of you have some idea of what OpenEO does. Maybe in the previous slide here, I can point out for those who don't know it, that there are 3 client libraries that users interact with in Python, JavaScript, and in R. And there's then, a Jupyter Lab environment and the web editor as the main interfaces to work with OpenEO. You can also potentially use it in your own desktop-based IDE, but most users use the Jupyter Lab environment these days to develop applications. This is just an example of kind of the abstraction level that OpenEO provides with the Python client library. And I like this because it's just 3 steps here. So you need to, connect with the OpenEO.cloud backend, authenticate using OpenID Connect, which is very convenient. And then you have the load collection step, right, where you just define a spatial and temporal extent, you define some bands. And based on this load collection call, first virtual data cube is instantiated here, level 1 C cube. And then you can just by operator chaining here add for example, the ARD surface reflectance process using force with some user-defined parameterization. So I think, OpenEO provides a really nice abstraction level, especially for people who come more from the science domain rather than from an engineering domain. And these are great efficiency gains, right? I mean, simply working with collections rather than in a file-based on a file-based system and concept is already a great efficiency gain, I think. Okay, and then user-defined processes. So these are different to the predefined processes in OpenEO that are defined at the API and client library level. So here, this is just showing you what OpenEO user process graphs look like. So OpenEO process graphs. So when you build your application or your script in the Python client library, what happens in the backend is that this Python code is translated into a JSON-based process graph, which is a language agnostic JSON-based definition of what this script needs to execute in the backend. The backend then interprets this process graph based on the specific implementation that's used in the backend. So there could be different technology stacks that interpret this process graph. And there is also, the graphical representation of the process graph in the web editor that you might be familiar with. So these OpenEO process graphs are the basic concept of OpenEO, and they are already very valuable in terms of abstraction, in terms of interoperability. So we can send this little JSON graph to any user and they could recreate it. We could execute it in any backend that supports the OpenEO API processes and has the data available. And of course, it's already quite nice for reusability. So, we could save this JSON recipe somewhere and just reuse it or send it to someone. So it's excellent. I would say it's a little bit less suited in terms of discoverability at this point, because there is no way to discover this graph. And this is where user-defined processes come in. And we'll take a look at this here a little bit more. So we can take now this Python script that we have developed in the first step, and we can now parameterize it. We can define the parameters that need to be used to call this user-defined process. So in this case, it's spatial extent and temporal extent. This is then, again, used in a load collection call. And then we can define our user-defined process by giving it a name, by passing the process graph that we had previously defined, giving a process definition, process summary, and passing on the parameters that need to be defined. And then there's another option to setting this as true and discoverable in the public. This is not yet fully working as it should, but that's how it's intended to be, that users can really fully discover it afterwards. Once we have done that, the whole script that we have built previously is available as a user-defined process. And there are then different ways of running this user-defined process. So one would be to use the data cube from process, calling the stats UDP that we have just defined. And that is already a very convenient way, right? So here you just need the connection to the OpenEO.cloud backend, and then you can call this stats UDP through the data cube from process function. And that will create a result data cube based on the script that we have developed in the previous step. What's also really nice is that the UDPs appear in the list of predefined processes in the OpenGeo web editor. So this allows users now to simply, drag and drop the script that you have previously developed into a new workflow. And of course, this also works on the Python client level, right? So you can integrate the script that you have just built in a new application at the Python client level, which is really nice. So this really enhances, the abstraction further. It really optimizes the interoperability and reusability of the application and the scripts, and it really strengthens also the discoverability. So in terms of fair data principles, UDPs have really nice properties, and that's why we're building on top of these next to the application packages. So I said that I wanted to talk about, how we are working on streamlining the operationalization of innovative EO applications. And there's just one initiative that I wanted to bring to your attention, and this is the application propagation environments. This is something that we have just kicked off in February. And the background to this is the following three observations. So on the one hand, all of the Earth observation projects that we run in ESA, their results typically become unavailable after a project ends, right? And this is especially true for algorithms and workflows, but also for value-added products. They simply disappear after the project ends, and there's no maintenance, there's no sustained accessibility. And the second observation is that we don't have any existing mechanism to transition R&D algorithms into more operational services. So it's also referred to as the last kilometer challenge. And the third observation is that many of our application projects spend a lot of time and effort on setting up working and collaboration environments from scratch, even though we have pre-existing solutions that could be used. We have some further recommendations from some ESA programmatic bodies that we should also strengthen the adoption of open science tools and interoperability, which further strengthened motivation to develop this application propagation environment initiative. So the application propagation environments, or APEX, will really foster the reuse and adoption of EO research and development results by providing a range of cloud-based instantiation and propagation services. And it's important to highlight that, rather than yet another platform, this is not another platform. APEX is rather an initiative that strengthens the integration and streamlining of existing European platform services and enhances the interoperability of these services. So the two concepts here are the instantiation services and propagation services. Instantiation services are very simple. It's basically a way of providing you or your project a working environment that has an IDE, that has a document repository, that has a WebGIS or dashboard without you having to develop this from scratch. So in a very configurable and tailored way. And the propagation services are a little different. So these really focus on making algorithms available as on-demand services in the cloud. And they focus also on improving the computational efficiency of source code. And, in the previous talk on BFAST, which I enjoyed a lot, there already we saw, also those teams have been looking at the initial source code that was developed and worked at improving the computational efficiency, which is really important because a lot of the source code we work with comes from academic teams or research teams, and they're not really, software developers. So if you go into production, large-scale production, there's large inefficiencies if you don't optimize the source code. And there's a couple of other propagation services, such as toolbox cloudification and the algorithm upscaling, which is also really important. So this is just a schematic of how the application propagation environments will facilitate the propagation and instantiation services. So there will be a central portal that we're currently building, in the apex.esa.int, where there will be a centrally aggregated place where all of the hosted algorithms will come together. So you, as a project PI that has developed algorithm B, you will be able to choose any of the existing European cloud platforms or Earth observation cloud platforms that there are to deploy your algorithm. Given that you are following our interoperability requirements, and also considering that the platform that you choose, platform 2, that it is compliant with our interoperability requirements. The interoperability requirements is something that we have developed with our industry partners over the last 5 years, I would say, and it's a living document. So it's not set in stone, and we're evolving these further. But for example, in there we recommend that the two best practices for transforming algorithms into interoperable on-demand services in the cloud should be OpenGeo UDPs or OGC application packages. But this is not set in stone. If you have a better solution, then we're happy to talk about that and consider that. Yeah. But for now, Apex will bring forward these interoperability requirements. And if Platform B complies with them, we will aggregate all of the algorithms that are hosted there in the Apex portal so that they are there available for execution through a graphical user interface, but also through a Jupyter Lab IDE. What we will also do with Apex is that for all of these hosted algorithms that all of your teams deploy on all of these platforms that are hopefully compliant, is that we will continuously verify and validate that these algorithms are not only available, but that they are actually resulting or producing the results that they are promised to do. And we will do that by defining, algorithm-specific small scientific benchmarks that we will then continuously test to make sure that these algorithms are not only deployed, but reachable and working. The second propagation service that's elaborated is the algorithm enhancement. So here we're going to build some tools and some guidelines that will streamline this often very labor-intensive process of source code optimization by providing tools for doing benchmarking and bottleneck identification on source code. And we will do this on the basic, source code level, like C++ or Python, but also providing algorithm optimization and enhancement at the OpenGeo or application package level. And then these optimized algorithms can then again be deployed on production environments like CDSE, the Copernicus Data Space Ecosystem, for running large-scale production. The other propagation service that I'm quite excited about is the algorithm upscaling. So the idea there is that we basically provide a computational framework that allows you to drop an algorithm that you have ready and that's running into an upscaling framework. And this upscaling framework will then upscale your algorithm to a very large geographic area or to a large temporal extent of data without you having to worry about any of the considerations that usually come with this, like tiling the area that we are working on, parallelizing over all of these tiles, dealing with issues such as coordinate reference system issues or projection differences, and dealing with intermediate files. So all of these data management aspects should be abstracted by this Apex upscaling framework. Instantiation services are, I think these are a little bit less relevant, but they're basically allowing you to request a fully configured instantiated working environment for any project that you might be working on. So all of these services will be available primarily to ESA projects, but we're also making them available in the network of resources to any pre-commercial users. So you will be able to request any of these in the next year or so. And maybe last point also in terms of accessibility of our science results. So far, often the value-added products that we generated in different projects, they have been, distributed across fragmented storage solutions, object storage buckets, managed by team A, team B. And we are now bringing all of these together, and we're building this EOPS, Science Data Product Repository on the ESA Cloud, which will then be linked, of course, with CDSE so that the community has one central catalog where all of the ESA EOP results are brought together. So it's not a repository for the EO data collections, right? It's a repository for value-added products and the results of the application and science projects. It's just an overview of the consortium that's implementing the Apex. So we kicked this off in April this year. And hear me? Hello? Yeah, okay. So we kicked this off in April, and it's we have funding for 5 years, but we are planning to make this a permanent thing in ESA EOP, so that this becomes a permanent solution. We also have something like 300,000 euros per year of flexible budget where we can bring in additional partners. So if there was some need on further optimizing BFAST or bringing it into CDSE, we have some budget to do this. So we're quite flexible. So feel free to reach out to us if you have any ideas. This is just another overview of the user-defined processes in OpenEO and application packages. And these are quite complementary best practices. So, with application packages, they're basically a Dockerized, a Docker solution together with common workflow language. So here you can actually use your native source code and just package it in a Docker container, and then use CWL to instruct how exactly this needs to be executed. And it has very nice properties for scaling. It's also it can be quite performant. And OpenEO UDP I already elaborated. So what we're trying to do here is to integrate these further and really exploit the synergies between these two best practices. Apex will then also provide, of course, a graphical user interface for executing all of these hosted and optimized algorithms. And this is just one example of the multi-output Gaussian process regression. It's a fusion algorithm that we developed together with some partners. This was so here we're actually using an OpenEO UDP to wrap around this Python implementation of MOGPR. And we're making it available through a graphical user interface for also codeless execution. This works really nicely, actually. Okay, the algorithm upscaling I already spoke about. So it's really about abstracting all these data management headaches that I'm sure many of you are familiar with. So also in OpenEO platform, whenever we did like continental scale demonstrations, it was always a pain, and also in Google Earth Engine, it's not very easy if you want to run something at continental scale for South America. It requires some special considerations, and there's not much abstraction of those data management burdens. So that's really something where we think we can make a meaningful contribution to the community. Okay, and then finally, this is mainly for your information. I think maybe not all of you are familiar of the ESA Network of Resources initiative, and this could be quite a helpful tool for you. I think so. The ESA Network of Resources is an initiative to foster the adoption and uptake of European cloud services, and it's also a sponsoring mechanism. So as you see here, the Network of Resources will also sponsor these European EO platform services and cloud services for you. Assuming that as long as you are not using it for commercial purposes, so everyone can request up to 5,000 euros per year and no sponsoring. If you have an ESA project, you can request much more sponsoring volume, so it's really nice. And it has proven very useful in terms of bringing real-world users to these European platform services so that they can mature and further enhance their service offerings, but also by creating a revenue stream for these platform services, that they are then getting from ESA in this case for the first couple of years, rather than from the users themselves. Here's a couple of links, and you can take a look. So that we sponsored over 1,000 projects by now, and initially for the first couple of years, it was mainly like infrastructure sponsoring, like VMs and storage. Then for the next 2-3 years, it became more and more sponsoring of platform service subscription packages. And now we're more and more transitioning to sponsoring data processing as a service and algorithm on demand as a service. So things like the wind turbine detection is offered at a price per 100 square kilometers. And we're planning to also develop this virtual credit concept that you can then spend across all of these on-demand algorithms. Exactly, and I put this one in because also, of course, OpenEO platform is available through a network of resources sponsoring. So you can, there's a free trial, but you can, of course, also request here the advanced or basic subscription packages. And there's also the research and university and research institute licenses, which provide you free 5 floating licenses for OpenEO platform, and you can request advanced credits. There's also gold, bronze, and silver developer support packages. So if you want to develop a more complex OpenEO-based solution, you can actually request developer support through the network of resources. I'm not sure how many of you were familiar with this, but I think it's quite a useful resource also for early career scientists. The last thing I wanted to bring to your attention is the ESA Future EO permanent call.
Patrick,
open
do
call.
you
Yes.
have slides, or because we don't see your slides now?
You don't see my slides. Okay, since when?
Since you started speaking about network of resources, I was thinking you were just wrapping up, so that's why I didn't want to interrupt you. But I think it was a good talk, so we didn't miss much.
Okay.
So it's like last minute. Okay.
Yeah. Do you see my slides?
Yes. Yeah.
Do you see my slides? Yeah. Okay. The last thing I wanted to bring your attention is the open call. So this is a call where you can propose ideas to us. There's funding for 200,000 euros over 18 months or 100,000 euros over 6 months. And there are 5 different activity lines. One of them is digital innovation. So if you have anything that's dealing on cloud-based capabilities, on open source geospatial software stacks or so, this is the place to go. And you can, it's competitive, but if you have a good idea, please get in touch with me and we can iterate on your idea. Here's a couple of more links that I can share in the PDF later. And exactly. And then I hope to see all of you at LPS 25. The location has recently been announced, so it's going to take place in next year, exactly in Vienna. So hope to see all of you there. Thank you.
So thanks a lot, Patrick. It worked very well, actually. Except that we lost like a minute of your slides, but I think it was actually a very nice talk. So I was thinking you are wrapping up and just giving tips how people can apply for network of resources, which I think it's quite relevant for the community we have here. I open floor for questions. Discussions. Yeah, so please, Raymond, go ahead.
Yes, hi, Patrick. Can you hear me okay?
Very well, yeah. Hi.
Okay, thanks. So nice talk, but I do have some concerns. So we're in a traditional, say, HPC type workshop, and you've been mostly talking about cloud and the cloud as an entity. So I think, first of all, the cloud is a difficult concept to actually grasp, because there's no such thing as multi-cloud and multi-cloud interoperability, to be quite honest about it. The other thing I'm missing is, for all the tools you are developed, how would they interact with, say, the Euro HPC ecosystem and the traditional HPC ecosystem for research IT and really achieve larger scales? So developing Slurm backends, for example, all of this seems to be completely absent in the thinking so far. And how will you also integrate with the Green Deal data space and the common European data spaces?
Yeah. Interesting consideration. And yeah, I'm aware that you guys are in this workshop focusing more on the HPC solutions. You have to say most of the applications and science work that you encounter in EO is mostly high throughput processing. No? So I don't know many cases where that really require HPC. I'm sure there are some, but I think most of it is high throughput processing. And there, the clouds work quite well. Also, consider that cloud computation is quite different today than it was maybe in 2010. So I think things have developed quite nicely. However, I have one example for you on how we plan to use high performance computing together with the tools that we develop, and that is actually related to GTIF, so the Green Transition Information Factory. And there are some stakeholders in the energy community that already use geospatial models to better understand the expected energy loads that come out of their hydropower storage energy plants. And they have a very hard time of accurately predicting what happens after heavy precipitation events, right? Their simple geospatial models do not pick those up well. And this is, of course, something where Destination Earth or Digital Twin Earth also come in, because they will work on these scenario analysis, and running different scenarios in terms of extreme weathers and extreme precipitation. And this is a very nice way where we can link kind of the front-end decision support tools that are based on, clouds in the back end together with HPC initiatives and platforms that do these scenario modeling tasks, to look at, what is the expected frequency of these heavy precipitation events and what does it mean in terms of inflow to our energy reservoirs. I think that's one nice example. We're also, in Esrin, actually, they're building this ESA, I think it's called Space HPC. So they're building an HPC in Esrin. So we will also have the chance to there interlink and interact with an HPC cluster that we will have on premise in Esrin. And I'm sure we quite a bit there, but yes, we haven't done much on that so far.
Yeah, just to comment on the HCC world, since I'm originally from there. So all of WLCD and all of astronomy are, of course, using also Slurm as backends for the HCC computing. So you're quite, as let's say, Earth observation, you're in a niche that seems quite far from the traditional research IT ecosystem. And hence you're missing also a potential funding opportunity, because there's a multi-billion-dollar research IT industry out there funded by national member states, that if you don't attach to that, you're actually locking out a lot of opportunities. On that point, you had, of course, the call that you presented last, up to 200K euros, where you could work with ESA to develop digital innovation. Would something like a Slurm backend for OpenEO, could that work there? And if
Absolutely.
so, a very technical question, maybe, or like a financial question. What kind of overhead do you fund through that? As you know, overhead in European calls are always quite low, which makes it risky to apply for. What does ESA have there?
So I think a Slurm backend for OpenEO would be super interesting, very innovative, and please let's talk further on this. I think that could fit really nicely. The open call is really competitive, but for digital innovation, we're receiving comparatively less proposals, so the chances are then not that bad. The funding for the open call is simply 200,000 euros, and overheads are assumed to be included in that. So, there's nothing on top of that. But of course, there are other funds and other calls that could be considered. Also, we provide network of resources sponsoring on top of the open call. So you could request, you could make a proposal for the open call and request at the same time a cluster in the a certain deployment in the Lumi supercomputer, I'm assuming.
Yeah. Right. Last comment on this one, then I'll let other people ask questions, is that one other thing I've noticed also in the way that ESA does it works and the traditional research IT organizations, so the national ones, is that ESA likes to do tenders and procurements. They fit very poorly as to what national research organizations can apply to, because they're not allowed to respond to tenders and procurements, most organizations. So that's also a concern, I think, going forward in the future. And you may have also seen that quite a few organizations have now dropped out of European Open Science Cloud because of this, as the EC has chosen procurement there as a method. ESA has done this for a while as well. So that's also difficult to respond to. So I think the open calls are potentially a much better chance. But just for your information, tenders and procurement are very difficult for many national IT organizations to respond to. Thanks.
Yeah. Okay. Well, I think, ESA has this industrial procurement policy, right? So it's really working with industry and not so much with the public institutions. That's like a heritage of the space hardware procurement, but it's an interesting comment. Thanks.
Okay. I have another question, actually a bit related to the previous questions as well about the funding. So thanks for showing the network of resources. And I was wondering, since you mentioned that ESA projects can get extra funding, I was wondering, what do you consider an ESA project? Because here we at the Open Earth Monitor project, our Horizon Europe project, and we would definitely like to make use of OpenEO resources to see if we can run everything that we produce also on OpenEO. I actually already checked it out, but what is available is only a kind of subscription for 1 year, but we are still going to be running for 2 years. So is there an opportunity to actually request more, or do we need to reapply after 1 year?
Yeah, the standard approach from the network of resources is that any request up to 5,000 euros can be approved for anyone. And it doesn't matter what the context is, the project context. And if you're in an ESA project, so that's an ESA, part of an ESA ITT, then that volume of sponsorship is much, much higher. That's the basic consideration. So Open Earth Monitor is a Horizon project, so I don't think it's not considered an ESA project. However, I think at least certainly 5,000 euros per year are available, and you should not be limited to a license for 1 year. I mean, no. But we can iterate on this maybe through email. We would be happy to support you there, and it should not be so constrained.
Yeah, thanks. I'll reach out to you.
Great.
Hey, this is Tom Hengel from OpenGeoHub. Just a comment. You mentioned that in this Apex vision, the WebGS and storytelling are still kind of unfinished or unready. So I'm thinking what could maybe work for people coming from open source intensive developers using open source. What works for us really good is to have libraries and packages inside, for example, a QGIS, that's a QGIS plugin inside Python and R library, then also other GIS. So have libraries contributed to this open source, because if you have that, then people will build their WebGIS very quickly, right? So if they have a very easy way to access inventories of data, computing resources, and the same basically what OpenEO does, it's just also in different open source libraries. And then you will have people building WebGIS like nothing. And connected with that, I did also see the OpenEO EO dashboard. EO dashboard seems to be open source. However, I think it's used only by ESA, if I'm correct. So the idea is to have a kind of platform to develop storytelling and WebGIS. But maybe you can reflect on that also. Tell us what do you think, how do you see that last things being resolved? Because it is true in Open Earth Monitor, in the Google Earth Engine, you do computing, you import the data, you do computing, and then you build up an app, and you can do it within 1 hour, right? And that's the whole process. Once you have the whole process, then people go, okay, I can really use the system now. If you have components and you cannot finish the whole process, then people say, yeah, it's useful, but I still have to develop other things myself. Yeah, so please, if you can reflect on that.
Yeah. Hey, Tom. There was now at least 3 parts to your question, no? And I think I forgot one part.
So for example, the contribution, what is your plan for contribution to open source?
Yeah.
If you do that,
okay, let me start with EO-Dash, because you were referring to that. So EO-Dash is the open source library that is used for the GTIF front end and also for the trilateral EO dashboard. And this is primarily developed by EOX as part of the Eurodata Cube contract. And we're using it in at least 3 different dashboard initiatives. EOX has made this fully open source, and they are really encouraging community engagement and community contributions. They're also planning to make this available or integrate this with OSGeo as a community project, and they're really seeking additional developers to contribute to the source code. So that's maybe one useful information for you to know. Because it's quite a versatile and quite useful solution for dashboards, but it would be nice if there was some additional contributors from the community beyond EOX. With Apex, we're actually developing a new dashboard WebGIS solution from scratch. because there's a little bit of, well, we need a bit of diversification in this case, and there's a little bit of functionality that we're missing with the current EO- implementation. However, for ARPEX, it's not the objective to allow users to develop WebGIS. So I tried to clarify that there's these two aspects of ARPEX. One is the propagation services and one is the instantiation services. So for ARPEX, the WebGIS is rather part of the instantiated environments that we're making available to project teams. However, what you refer to with GEE, the codeless apps that GEE offers is a really cool feature. And I remember discussing this also previously with OpenEO platform, something that would be really cool to make also available for European EO services. So codeless apps. And I think with ARPEX, we're going a little bit into that direction, at least for the hosted algorithms, to make them executable through graphical user interfaces. There will be some kind of WebGIS element, but that's a little different from the WebGIS and scrollytelling support that we're offering as part of the instantiated environments.
Thank you, and please come in October. Come to YASA again. Bring your developers, please. Come and interact, and let's create things together. Yes. No, Tom, I mean, we have, I appreciate all of the outreach that you guys are doing and, the discussions that we had with Gilberto's team on SITS recently. This is all very good. So, yes, we'll plan to come. Okay, Tom is dominating too many of the questions here. Who else has a question? Just kidding.
Yes, I would actually encourage also participants to ask. So if you have, I'm quite sure you have a lot of data you are working on, so it's a unique opportunity, to ask Patrick, and so how you can be onboarded. Yeah, so please, Yufeng.
I'm Yufeng from OpenGeoHub. I'm working more on the technical side, so I would like to know what's a current solution for the cloud format that you use for raster and also the factor data. So that would be more lead my direction to work hard with what kind of part of the trend that people are using currently.
Yes. So I was referring a lot to the interoperability guidelines and the interoperability best practices that we're also using in tender calls. So when we issue a tender, we now have an annex there that says, like, you have to follow these interoperability guidelines. And there is, a requirement in there to make raster data available as cloud optimized formats, so either as COGS or as ZAR files. So no big surprises there. It's kind of the community consensus, currently, I think. And for vector data, I think it's less specific at this point, but I think like vector tiles and GeoParquet are, currently kind of finning a lot of traction and adoption, and probably will integrate this sooner or later into our interoperability guidelines, which are, by the way, also online and publicly visible on the GitHub, and they're open for comments. So if you feel like these interoperability guidelines that we're applying there are not really fair, or they fail to recognize something, then please let us know and engage.
Giuseppe.
Hi, Patrick. This is Giuseppe Matulli. I send a research proposal to you. Could you please take a look? Directly speaking, because I sent 4 times. Thank you.
Hey, Giuseppe, I'm not sure. You sent a research proposal to me?
Yeah, it was our agreement to have a kind of pre-discussion and submit an abstract of the research proposal, but we never get back. So direct question. Thank you.
Okay, then apologies for that. I'm not quite sure when this came in, but if you could just resend that request.
Okay, I will resend it.
Appreciate it. Thank you. Is this a follow-up from our last meeting in Bolzano? At the,
yes, it is. Okay. Thank you.
Good. Yeah, one question from my side, Patrick. This APEX, it sounds very interesting initiative. I still struggling to understand exactly what this means. So first of all, the time frame. What is envisioned by ESA? What would be the time frame for such kind of let's call it projects? And Yeah, and about this upscaling, so like removing this burden of parallelization and everything. So is it that the applicant should come with his own team working on that, or ESA already has like experts that will help onboarding this on backend?
Okay. So the upscaling, there's no need for experts to come. It's basically just a computational solution that allows you to drag and drop an algorithm and say, like, I want to run this for, all of China. So in that case, there's no onboarding or anything. It's just, you need to develop your algorithm following some certain considerations and guidelines, but then you should be able to plug and play your algorithm into this upscaling framework of Apex, and you will then be able to run this over China without having to worry about any of the data management aspects.
Okay, so there will be a framework already designed by Apex. Yeah. Okay.
Yes, and the framework in this case is more like a tooling, right? It's like there might be a webmasks or something that allows you to do this upscaling, developing this. What else? In terms of algorithm hosting, so the refactoring of your application into an OpenGeo UDP or an application package is something that would have to be done by you. We have some developer support available for some cases, but we're going to make a lot of resources available that will make this easier, and also hopefully also some tools that will do an analysis of your source code and then recommend should this be packaged as an application package or a UDP, and maybe also some performance efficiency tools that make this refactoring easier. In terms of timeline, we're starting now already with the first candidates for algorithm enhancement and for toolbox cloudification. And so these are being started now. However, it will be a very iterative process. So in the beginning, it will still be quite manual, labor-intense activity. But then as we learn and develop the tools that support this, it will be streamlined. And then after 2 years, these propagation services will also be in the network of resources. So you will then also be able from the global pasture watch or whatever, to go to the NOAA and say like, okay, we want to request algorithm optimization for this source code. We want to request upscaling to global level with this algorithm and stuff like that. Other parts of the Apex services will already become available towards the end of the year. So a lot of the instantiation service components will already be available by the end of the year. And we hope that we have the portal up after the summer. So that's the central point where all of the algorithms will be brought together in a central environment where you can execute them, where you can check their functioning and availability. And hopefully, we really see this as kind of a way to aggregate all of the ESA EOP applications activities, to bring them all together in the same format, reusable for the community.
Okay, thank you very much. Thanks a lot for a very interesting talk. Pity you will miss actually today our social event, so the local Luxembourg beer.
Yes.
Yeah, but it was anyway great to have you also online, and hopefully in one of the next instances, we can have you also on site. And maybe there is a chance also for ESA to integrate this event for the next Living Planet Symposium, so we can do something similar, or just repeat it in 1 year.
Absolutely, yeah. I mean, there's a lot of side events for LPS. There's a lot of side events, so that's a good idea. Yeah. And also, the public call for sessions will come out in July, I think. So stay tuned for that, and that's a great idea. Thanks a lot for the invitation, Milutin. Wish I was there for the beers later.
Yeah. Okay. Great. Thanks a lot.
Thank you.